we are transitioning, remember, from thinking about sine, cos, and tan as trigonometric ratios, right? Within a triangle, there's this quantity, this length, and we're comparing them, right? We're moving away from that and thinking, well, what are they as functions? Just as rules. And what we did was we introduced a means by which, not the triangle, a different geometric figure we used to define the trig functions. What were they? What was it?
Unit circle.
So the unit circle, wasn't it? Okay, which is why, and I'm just going to quickly draw one for myself. You don't need to because you'll have your one from last lesson to refer to, and you'll need to. The unit circle, we said that we defined the coordinates based on the trig functions. Okay, we said anywhere on the circumference, wherever you're on the circumference, the coordinates of that point will be cos theta, sine theta, where theta is the angle subtended, there's a nice familiar word for you, subtended at the origin between your point, the origin, and which side of the x-axis? The positive side of the x-axis, over here. Okay, so for instance, in this diagram, my theta would be there. Okay, so we took this idea and we noticed it was very, very powerful. Okay, because number one, it took us outside of what we would call the first quadrant, right, which is the acute angles. We can look at angles of any magnitude, right? And not just that, you looked at boundary values for these, values which wouldn't make sense in a triangle, like this. If theta were, say, 90 degrees, okay? From the unit circle definition, what's, for instance, cos of 90? Have a look at it. Cosine is the x-coordinate, which for that point is 0, right? 0. And of course, its attendant y value would be 1, which is why we say sine of 90 degrees is 1. It comes from this. This is the definition, okay? So now what we're going to do is we're going to transition everything. Well, if it's a function, you can graph a function. You can graph any function you like, okay? Based on what values that you get, right? So here's the way we're going to approach this. Instead of having x's and y's, okay, just to remind you that what we're dealing with here are angles, I'm going to call this the theta axis, right? And then, well, for this graph, because the first one I'm always going to start with is sine, this is the sine theta axis. Now, I know you're used to saying, well, x and y, but y is just another name for whatever function you got in there. Like, say, y equals x squared. You just as equally could have named the axes x and x squared, because y is equal to x squared, and that would give you this, okay? So we're going to graph theta against sine theta. All right. So where we're going to begin is we're just going to think about the bits that are easy, right? Some bits are very easy. If I look, for example, at an angle of 0, okay, down there, okay? I'm thinking of sine. So which of the coordinates am I thinking of, x or y? I'm thinking alphabetically, right? So sine is a y coordinate, right? So what's the y coordinate of this angle? The answer is 0. So sine theta for theta equals 0 is 0, okay? And then I can keep going through the angles. I'm going to start by using the important points there, those boundary points, because they'll give me sort of as far as I need to go, right? So we were talking about 90 degrees, okay? So I'm going to put some markers on here. I'm going to put 4. You can probably see why it's going to be 4, okay? So we'll make that first one 90 degrees, right? Sine of 90 is 1. It's 1. Now before I mark in, because I don't have a vertical scale on here, right? Just don't answer this yet. Just think about it in your head. Where should I put 1? Should I put it like really low or really high? Where should I put it? Yeah, Brendan?
Really high, because it's the highest.
Okay, I'm going to put it right up there. In fact, I'm going to make it the highest value I can get to. And the reason why comes back to the fact that we're on the unit circle, right? If sine, and, well, I mean, cos is the same, but if sine is the y value, right? The very highest I can get is 1, because that's the highest that goes on the unit circle. And conversely, the very lowest I can go is -1, okay? So right away, I've got a range for my function here. So for sine equals 90 degrees, I'm up at 1. I'm going to keep going around the circle. For theta equals 180 degrees, I've got a straight angle there. And so what's the y coordinate? What's the sine value? I'm back to 0, aren't I? Okay? That's for 180 degrees. 180. And then I can keep going. You'll see what's happening. I've come round to this side down here for 270 degrees. So sine theta for that is -1. Okay, so that's for 270. And then my last value is 360. Okay? Now, 360 takes me back to where I started because it's a circle, right? So that's why I'm on 0 for 360 degrees. Now, I could keep going, but I don't need to. I don't need to, do I? Because look what happens, right? As I keep going, say, for instance, I said 450 degrees, okay? It's the angle subtended at the center, right? So where's 450? I have to go all the way around, that's 360, and then I have to go another 90, right? That would get me to 450, yes, okay? But that's exactly the same thing that happened when I went up to 90, right? So this pattern is going to repeat, right? Because I'm literally going around in circles, okay? So that's where I'm going to stop drawing. Before I connect the dots, right? I could connect the dots in a variety of ways. And in fact, one of the reasons why I'm making a big deal out of this, even though many of you have seen this before, is because I want to highlight some of the bad ways to do this, okay? For instance, if I told you, here's 1, 2, 3 points, okay? 1, 2, 3 points. I could draw for you, I'm just going to draw it over here on the side. I could draw for you a graph that passes through those 1, 2, 3 points that is exactly a graph that you have been working on over the last few weeks, right? For instance, let's just draw that part there. 1, 2, 3. If those are the points I gave you, how could I join these up? Any suggestions? Yeah, me too.
You can draw absolute value.
Yeah, excellent. I can just chuck a straight line through there, right? I'll get to that in a second. Okay, so for starters, that satisfies the points, doesn't it? Right? Because I don't have many points, I don't have enough detail on what's going on. And what would the equation of that be? I have no idea. It would be minus absolute value of x plus something, 90 degrees, whatever. Okay, you get the idea. So that's not going to work though, because it's quite clearly a different function. It's the absolute value. Another suggestion that would still pass through all 3 points is I could draw it with a semicircle, right? Just the last quiz we did, there was the equation of a semicircle in there. You could contrive that equation. Both of those aren't good fits, right? So I need a little more data in here to fill this in and get an accurate shape. Now, I'm going to stop talking for a second. In between 0 and 180, even between 0 and 90, okay, we know a series of exact values that will give us surds that I'd like you to go ahead and plot in here. Do it as accurately as you can. I'll give you a couple of minutes. You'll have 0, got that, 30, 45, 60, and then 90, which we already have. So I'm looking for 3 values, and they're going to give us a shape in there. Off you go. So I'm going to quickly do some of this by hand. Well, I don't have a choice, okay? 30, 45, and 60. 30, 45, and 60. Now, because I'm doing sine, right, I know right away that sine 30 degrees is a half, right? So think about it this way. I've only gone a third the way horizontally, but I'm already halfway up my vertical scale because I'm at a half, right? So I've climbed, my gradient in there is quite steep, right? When you get to sine 45 degrees is 1 on root 2, which as a decimal is 0.707, I think. So by halfway, I'm already like 3/4 the way up. So this is the kind of shape you ought to have. Okay? That's the kind of shape you should be having. Now you can go ahead and you can test out what's happening here on the circle. Because of this symmetry here, right? As I go from 0 to 90, the y value is increasing. When I go from 90 to 180, the y value is decreasing at exactly the same rate in reverse. Does that make sense? Like I'm literally climbing down the other side of the circle. Okay? So I'm going to get the same shape, but I'm going to get it downwards. Okay? And now I'm going to continue my pattern to meet up with all the other points I've got. Okay? Now I have talked before about templates, okay? That's a really easy way to just nail it straight away. But in the absence of a template, there are 3 important things that I'm looking for. 3 important things. Number 1, this gradient here. Okay? See that gradient, right? There should be a gradient. It mustn't be a vertical tangent like it would be if it was a semicircle or an ellipse. Okay, so I'm looking for a gradient there. In fact, if you did everything to scale, and we'll get to radians shortly, that gradient there is in fact 1. Now it doesn't look like 1 on my diagram and almost certainly on yours because our scales are different. And that's fine. As long as you're consistent, that's fine. Okay? But my point is there must be a gradient. It can't be vertical. That was number 1. Number 2, I'm looking for a smooth transition here as the gradient goes from steep and then sort of levels out. That should happen smoothly. We joked about this absolute value thing before. I've seen loads of graphs that sort of look like an absolute value all the way, and then they're kind of like, oh, I'd better turn around. I'll just chuck a little thing there and then just keep going, okay? So it's like an absolute value in everything but these little corners, okay? It's still not okay. There should be a smooth transition. That was the second thing I'm looking for. The last thing is up here at 90 degrees and down here at 270 degrees. Okay? These things are what we call, they have a couple of names, but the most relevant name for this is, it's a turning point. It's called a turning point because the function literally turns around. It's not going up anymore, it's not increasing, it's decreasing. That turning point should be nice and gentle. In fact, when I'm drawing graphs freehand, often the turning points will be the first thing I draw. Right, to make sure I get them right, and then I connect everything else. Okay, so what are the 3 things? Number 1, what's happening is I pass through the axis here, and here, and here, and I can keep going. Number 2, am I smoothly transitioning the gradient? And number 3, what's happening at the turning points? Am I getting that shape right? Okay. Now, we have finished what's happening over here, okay? But there's a whole half of my graph that is missing, right? I've got all of these negative angles over here. Now, negative angles don't make sense when you're in triangles. But in the unit circle, there's no reason why you can't do a negative angle. What direction do positive angles go in? What direction? They go anti-clockwise, right? Don't do that, right? Yeah, okay. Yeah, all right.
Yeah.
I'm going to stop doing it because I'm going to confuse myself. Anti-clockwise, right? So therefore, negative angles should go clockwise, right? They still start at the same point. So they still start at that positive x-axis, but for instance, minus 45 degrees would go down to here. Okay? So you can see I'm going to get the same graph, but it's going to be reflected across. So let's just finish drawing that. I should have said maybe a 4th thing, which I'm pointing out because I haven't done it very well on this. My turning points should all be at 1 and minus 1. They should all be there. It's very hard to do it by hand, which is why I tell you guys to get a template. It's just so easy, okay? But there you go.